Okay, grade 9. This is your chapter 4, 9 for. That is, oh, welcome back, Paige. Thanks for coming. So, what we have here is we have 9 questions that are decent review questions for your test. Most people say you can't read my handwriting, but tough luck. Uh, Part of it is being able to decode, so hopefully I'll read them for you and you can answer them. So if you're trying this at home to practice for the test and you really have a terrible memory and you probably won't remember the answers to these anyway, press pause at each question, do a real quick version of it, press unpause, watch the video, and see if you did it correctly. So the first question says, if a square with an area of 25 meters squared was redrawn at a scale factor of 0.6, what is the new perimeter? So obviously in a question like this where there is no picture given, the first thing y'all should do is draw the square and put area equals 25 meters squared. Now once you have that made, so once you've drawn it, the first step you need to do is say, well, and it's a multi-stepped question. So if the area is 25 meters squared, then the side length must be 5 meters. Okay? Now if it was redrawn at a scale factor of 0.6, we know that a scale factor of 1 is the original image. So if I multiply something by 1, it's going to be that. If I multiply something then greater than 1, greater than 1, oh, whatever, it's going to be an enlargement. And if it's less than 1, it's going to be a reduction. So if I multiply it by 0.6, what I'm really doing, a scale factor of 0.6 is going to be 60% of the size of the original image. So each of these is going to be multiplied by 0.6 to give me the new image. And when I multiply 0 or 5 by 0.6, I get 3. So therefore, the new square will be 60% smaller. It'll be 3 meters, 3 meters, 3 meters, and 3 meters. And therefore, it will have a perimeter of 3, 6, 9, 12. It will have a perimeter of 12 meters. Okay? So the answer for question 1 is, what is the new perimeter? The perimeter would be 12 meters. Question 2 gives you a picture of a shoe, and this says this is a picture of Leah's foot. And it says, what is Leah's, if this is the scale. So scale, we have learned, if we learned anything in this chapter, we learned that scale is the diagram's size divided by the actual size, or D over A is what scale would be. So when I see it like this, 1 to 0.45, the first number in my ratio is the diagram, and the second number is its size in the actual. So this means for every 1 centimeter in the diagram, so every 1 centimeter in the diagram, the actual foot of Leah's is 0.5 centimeters, or roughly a little bit less than half a centimeter long in the actual size. So I'm going to always put this as my starting point. I'm going to remind myself that scale is D over A. And then what I'm going to do is I'm going to redraw this one as 1 over 0.45. Because this scale and this scale are the exact same thing. So the first thing I'm going to do is write 1 over 4.5. And then I'm going to set it up as a proportion, which is an equivalency to another ratio of two things. So the other one, if this is the drawing, then I know the drawing of her foot is 40 centimeters. And the question says, what is her real foot? So I don't know it. So I'm going to put an X there. Now, once you've set up your proportion, this is a grade 8 question now. Once you've set up your proportion, you can solve it a couple of different ways. You could say, well, I multiplied this by 40 to get that. I can multiply this by 40. You can take your calculator out and say decimal 45 multiplied by 40 is 18. 18 centimeters. So therefore, Leah's real foot is 18 centimeters long. That's one way to do it. Another way you could do it would be to create an equation by multiplying across your proportion. So 1 times x is x, 0.45 multiplied by 40 would be the other side of your equation. And 0.45 multiplied by 40 is also 18. So x would equal 18 as a second way you could solve it, okay? Either way, you found out that Leah's foot, using proportional reasoning, is 18 centimeters long. Question 3, we have a diagram of a tree that's only 18 centimeters tall. And it says the scale, it gives you right here, is 1 to 58. So that means for every 1 centimeter in the drawing, the actual tree is 58 centimeters. Because this is your D, and this is your A. So the first thing you're going to do is write down your scale as D over A. You're going to write down 1 over 58 because that's the scale that's given to you. Right? And then you're going to make is proportional to. Now this tree is obviously not the real tree unless it was a bonsai tree. So it's a picture of the tree, which means it's the diagram of the tree, which means it's the top number of your proportion, and we don't know the actual. So again, I can multiply by 18 and multiply by 18. Take 58 and multiply it by 18. I get 1044 for the height, or therefore the tree is 1,044 centimeters, but that would be a unit of measurement. We would never say the tree is 1,044 centimeters, since 1 meter equals 100 centimeters. To convert this into meters, I would divide by 100, or move my decimal 2 places over, or 10.44 meters tall. Okay? And again, you could have also multiplied it across the proportion to create that. Now, what you could have also done is determined the scale factor, but since these are better served as proportions, we'll just keep it like that. Good. Your next question, there's no picture given this time. It says, I am 187 centimeters tall. If I am drawn to be 22.44, what scale factor was used? So what scale factor was used? So scale factor is another formula, but it's just simply your D divided by your A will give you your scale factor. So in this thing, that's my drawing. So I'm going to put 22.4 there, divided by my actual height, which is 187. And then I grab a calculator. 22.4 divided by 187 is, oh, did I do that wrong? Did I make a mistake on the 22.4? What is it? Oh, 4. Thank you. There's another 4 there. Divided by 187 equals 0.12. So therefore, when you take my height of 187 centimeters and you were to multiply it by 0.12, you would have created the drawing of me that was 22.44 centimeters. So by multiplying an actual thing by a scale factor, you're going to create the enlargement or reduction. And remember, if your scale factor is less than 1, the picture you draw will be a reduction. If the scale factor you multiply your actual by is greater than 1, you will be creating an enlargement in your diagram. And the third part to our little story narrative is if Leah wants to be drawn next to me, and she is 155 centimeters tall, how tall would her drawing be? Okay? Well, you just have to go, this is quite easy actually, because if you go back, we've already determined that the scale factor for the drawing is 0.12. So all you would have to do is take Leah's height and multiply it by 0.12. And you go 155 times the scale factor would tell you that Leah's drawing is going to be 18.6 centimeters tall if she stands next to me in the picture. So I'm 22.44 centimeters tall in the picture, and Leah will be 18.6 centimeters, or something that looks like this. There's me with my wonderful beard, and there's Leah. Not quite that short, but maybe a little bit bigger. Let's make Leah a little bit bigger. That's too short. Oh, is that working? Oh, well, Leah is now that tall. Next picture. Next question, sorry. Next question. Oh. we have two triangles here, and the question says, is triangle ABC similar to, this symbol here means similar to, I spelled similar wrong, similar to the other triangle. And similar triangles will have two qualities. They will have angles, corresponding angles. The first thing they have is corresponding angles, angles that are equal, which is not important for this question. And the second thing they will have is they will have proportional corresponding sides. I'm aware my handwriting is messy. This means the following, that if I take this side here, and if it's proportional, if it's similar, then those two sides will be proportional to these two sides, which will be proportional to these two sides. Or another way to say that is that because this is an enlargement, each one of those sides in ABC will be multiplied by the same scale factor to create the enlargement. So let's determine our scale factor. So as you can see in the triangles, I put A and D, and you could do that with these questions where you know all the sides with both. It doesn't matter what you put the A and D. I like to put my A in the smaller one because then I know I'm multiplying by a scale factor greater than 1. So to determine the scale factor, I'm going to choose any side. I'm going to choose the hypotenuse of my D. So since scale factor is D divided by A, I'm going to take my D's hypotenuse of 9, and I'm going to divide it by my ABC hypotenuse of 5. And 9 divided by 5, actually I could probably do that without a calculator. 9 divided by 5 is 1 4/5, which is 1.8. But of course, if you take your calculator and go 9 divided by 5, it does the work for you. 9 divided by 5 equals 1.8. So therefore, your scale factor that I used in this actual triangle is I multiplied every one of those sides by the scale factor of 1.8, because that's what I multiplied 5 by to get 9. So if 4 times 1.8 is 7.2 and 3 times 1.8 is 5.4, then these two triangles are proportional. So then I say, okay, I'll take 4 and multiply it by the scale factor of 1.8. Press the equals button at 7.2, which is what this was. So 4 times 1.8 was 7.2. And if 3 times 1.8 is 5.4, 3 times 1.8 is 5.4. Yes. So therefore, all of the sides of my original smaller triangle were multiplied by a scale factor of 1.8. So therefore, the answer to this question will be yes, they are similar triangles. And of course, you know how much on your summative tests I like to do true-false. You can be absolutely guaranteed that this question will appear on your summative test. Your next one, I shouldn't put the D and A in there because it won't belong there. So I'm gonna move these over here. You have two triangles. You have a small one and you have a big one. And it says, what is the missing side length? I guess we should have said first is that these two triangles are similar. Because if I don't say that, then their sides will not necessarily be proportional. Until I say that they're similar, we don't know if their sides are proportional. So I should have said that first, but I think you all assumed they were. So given the fact that they are similar, and I know these two sides, but I don't know that side, the first thing you're going to have to do is define which one was your original and which one is your diagram. And your actual should always be the triangle that you know all of the sides for, and your diagram should be the one that you don't know one of the sides for. So the first thing I'm going to do is write A in one of them and D in the other. And then, of course, you can do it one of two ways. You can determine the scale factor. What did I multiply 12.6 by to get 8? Sorry. Yeah, what did I multiply 12.6 by to get 8? And I know it has to be a reduction. So I know that whatever that number is, it's going to be less than 1 because I made a reduction in my picture. And I'm going to determine it by saying, well, scale factor is this. So scale factor will be 8, which is the diagram's side I know, divided by the other side I know, which is 12.6. That's corresponding side. Take my calculator, go 8 divided by 12.6. Did I do something wrong again? Is that right? I should have thought that went through. Oh, well. 8 divided by 12.6. Let's do that again. 8 divided by 12.6. Yeah, I didn't think that one through. Oh well. The scale factor. Wow, look at that. Look at those decimals. So right there, if we look at that, 634920, 634920, 634920, 634920 repeating is the scale factor. Okay. So that means that I multiplied this by 0.634920 to get 8. And therefore, in order to find the other missing value using scale factor, I'm going to have to go 0.634920. Now, here's the thing. Obviously, I'm going to have a hard time putting that into the calculator because I can't put repeating decimals. So here's how I'm going to do it. I'm going to go 8 divided by 12.6 again. 12.6. And it's going to give me that long sequence of numbers again. I don't have to type it in because there it is. And I'm going to take that long sequence of numbers from my calculator and immediately multiply it by my 10.4. Right? I can press the equals button. And it's going to say that x is going to be approximately equal to 6.6-ish. I'm going to put an approximately equal sign there. So x is approximately 6.6. Okay? Its actual length is that big, long monstrosity of a number. And I think we have a repeating pattern. So 603 is there, and then it goes 174603, 174603. So technically, 174603, 174,603. Okay, so it's 174603. So it's 603 here, and then that's this. So there is the actual value of x if you want to write it exactly. Was that it? 6 right here. 6 here? Right, 6 there. 6.603, 174603 repeats to infinity. Okay. Now, that's the hard way with scale factor. If you set it up as a proportion, it's much easier. So I'm going to take a different color marker. I'm going to do the same question a different way. So I'm going to put scale is d over a, and therefore this side to this side, or sorry, backwards, this side to this side, my d over a, or my 8 over 12.6, so my d to the corresponding side of this is proportional to the x over 10.4. And this will actually work out a lot easier for us because algebra is a lot easier to solve than scale factor. So 12.6x will be equal to 80, and 3.2 is 83.2. Take my 83.2, 83.2, and divide it by 12.6, and it gets you the exact same answer we got before, but in an easier, different way. So we get the same answer using proportional reasoning as opposed to scale factor. Kelly, do you want to help me out here on the next one? I thought you wanted to help out. Oh no. So I heard you talking. I just thought you wanted to help me out on this one. No? Okay. Did I miss one? Did I skip one? Oh, I did skip the Mr. Pendleton one. Don't worry about it. We'll just go to this one. And the last question gives you this, and you can be guaranteed this will appear on your test. So really, what we have here is we have this green triangle here, which I'm going to redraw, and I'm going to bring this one down. And then we have this smaller one that I'm going to bring down. And we know that both of them have 90-degree angles because they're right here. And both of them share this angle right here. So we know that those two triangles that are green are going to be similar triangles because this angle is the same, this angle is the same, and since all triangles have angle or three angles that have to be 180, this one here would have to be equal to this one here. So based on the fact that if all three angles are the same, then the sides will be proportional. I can now say definitively that these two triangles are similar. And because I now said that, I could put x here, and I could put 4 here, and I could put 8 here. And the only other thing I have to figure out is how long is this side. And I know for that one, it's 18. So therefore I have set up two triangles. One side's missing. Of course, I know all of these, so I'm going to call this my A. I'm missing one of these, so I'm going to call it my D. And again, you could solve it one of two ways. You can determine the scale factor, or you could set it up as a proportion. Let's set it up as a proportion first. So D over A is how we're going to set it up. So 18 over 8. 18 is my D, so I'm going to put that in the top. 18 goes where my D is. Over 8 is proportional to, my D is X, and my A is 4. Once I set it up like that, my equation will be 8X equals 40 and 32, which is 72. Divide both sides by 8, and X equals 9. Is that right? Did I solve that right? Everyone get 9 for that one? Okay. So if you solve it using proportional reasoning, you get that. If you solve it using scale factor, you're going to take your D over divided by A to calculate your scale factor. This is the D I know to its corresponding side. So 18 divided by 8 will tell me what I multiplied my actual diagram by as a scale factor. 18 divided by 8 is 2.25. So therefore, I multiply this by 2.25 to get this. And I will multiply this by 2.25 to get this. And 4 times 2.25, of course, is 9. 4 times 2.25 is 9. So again, another way to solve X is 9. Sit down.